Good morning, friends. Today we'll be seeing that what is the relation between a pointer and array. Just to revise array quickly, array is a collection of same data type elements which is declared using square bracket and size specified inside that square bracket. While doing so, you tell the compiler to reserve memory for 10 consecutive integers and the collection is named as A. So, there will be 10 consecutive memory locations which will be reserved for this collection called A, or array called A, which is a collection of 10 integers which are stored consecutively in the memory. If you have 10 different integers like A1, A2 till A10, in that case they may be stored in various different locations. The locations in this case may not be consecutive. Consecutive in the sense they appear in the chronological sequence, right? For example, if the memory address here is 8000, this would be 8002, 8004 and so on. The gap is of value 2 because it is a integer array where a single integer value requires 2 bytes to be stored. Now each element in the array is identified using its index value. This index value is again represented using the square bracket and generally it starts with index 0. So this becomes A of 0, A of 1 till A of 9. Now this entire representation and the way compiler talks to the memory is based on pointer arithmetic. Here you can see that we have not used any pointer variable. Although not using the pointer variable, our compiler is inherently using pointer representation to store the arrays. So now let us see how it uses pointers. When you are defining integer A of 10 and the memory is allocated, your A represents the address of 0th element. When you simply write the variable name, when the variable is an array, your array name indicates the address of 0th element. Now when in your programming logic, whenever you are talking of any of the elements, say A of 5, the A of 5 value is calculated using the logic A plus 5 into the scaling factor. This scaling factor depends on the data type. Here in this case, the data type is integer, and in the conventional systems, the integer requires 2 bytes to be stored. So here the scaling factor would be 2. Right? Now suppose the address of 0th element is 5000. Right? As you know, the consecutive variables will be stored in 5002, 4, 6, 8 and so on. My 5th element, when I write A of 5, right, it is actually 0, 1, 2, 3, 4, 5, 6th element. right? Now you can see here, if A is 5000 plus 5 into 2 is 5010. So my fifth element would be located at location 5010. So when I write A of 5, this would be value at address specified by A of 5, and this is how it is calculated, right? You can see here, this is 5000, 5002, 4, 6, 8, 10. Now in this scenario, when you are using arrays inside a function, or you are passing arrays to a function, you will require the entire array, the changed array, to be reflected in the calling function, which goes for call by reference. Right? In this case, whenever you are passing, so in my main function, right, I am calling a function called, there is an integer array A of 5, which I am passing to a function, right? How I generally have to do is function A comma 5. So in this function call, what we generally pass is the array name and the size of the array. The function header will contain function integer x. Here the square bracket will tell that the variable that you are catching here is an array, and the size of the integer is cached as another variable. Right? Again here, whenever you are working in your main function, there is a memory location which is indicated by A, and in your called function, there is a memory location which is indicated by X. So there are two different arrays you would be working on. The only thing common would be the values that you are passing from your calling function to the called function. Now what I want is to reflect the changes that I make in variable X or the array X to the original copy of the array. Right? For example, I am sorting the array A in this particular function. So the sorted result which I create here should reflect in this particular array without returning anything. Now how this will happen? So this can happen using call by reference. Now when you say call by reference, what you are going to pass from here would be the address, right? Now when you are passing address here, right, at that time in case of normal variables we write address of X, but here my variable is an array. When I am writing array name, it itself indicates address of the first element. So here in this case you need not write address of A. You do not write address of A. While passing A itself, you can say that you are passing address of the first element. Right? Now the change would be here in the header of your function, where instead of simply writing integer X and square brackets, you will be writing integer value star X. So this will be a pointer that will catch the address of the first element. So if this is 800, X will contain 800. Right? Now when you say that X of 5, you are working on X of 5. Right? This means you are working on this particular address plus 5 into the scaling factor. This itself is indicating the address, right? Because you are here in this case, you will not have to use the asterisk sign as you use with the normal variable. So what all logic for the array manipulation you are applying, you can apply right away without using the asterisk sign. Right? Although the value where you are catching the variable is a pointer, here you do not require to use the asterisk sign. Right? Because this in itself, when you are saying X of 5, in itself is calculating the address. It is taking this as address only. So it will go to that particular address. Say the address stored here is 800 plus 5 into, what is the type of this integer? 2, right? So it will jump to the address which would be located somewhere here and will manipulate the value which is located here in the original array, right? So here, without using any extra symbols, you will actually be using the same array manipulation symbols or instructions which will directly be used even if your variable in which you are catching the values would be a pointer. So here you can see an example where my main function is having an integer array x which has 5 elements, and you are calling a function sort where you are passing x with its size. Now this sort function is catching it as an array, right, and performing the sorting operation, right? Now if I want to go for call by reference, the only change that I have to make here, there will be no change here in the calling function because x itself is indicating address of the 0th element, right? Now what change would appear here is, instead of a and square brackets, what I'll have to write is pointer a, right? And in my rest of the program, I have to make no change. There will be no asterisk sign or anything anywhere, because when we are using arrays, it inherently uses pointer arithmetic, right? And this itself is talking about address. When I write the pointer's name, it indicates address, right, of the 0th element plus the scaling factor into the element value, right? So the index value. Now this indicates that whenever you are going for array manipulation in a function, it is more advisable to always go for using a pointer, because whatever changes that you are making on the array will be directly reflected to the calling function, right? And that is what we generally want when we are working with arrays, because arrays are multiple values which we cannot return using a single return statement. We may require to return some other values also if it is not a sort function and it would be something else. We may sort and then we may also return something else. In that case, the sorted array will not be reflected in the main function if you are not using pointer, right? So using pointers to represent and work with arrays is simpler than